find the point of intersection of the lines xyz equals negative 2, 1, 5 plus t times 3, 1, negative 2, and xyz equals 3, negative 6, negative 3 plus s times 1, negative 4, negative 3. Now in space, two lines are likely to not intersect. Imagine a line in the floor and a line in the ceiling. Those two lines, assuming that the floor and the ceiling are parallel to each other, those two lines would not intersect. But maybe they do in this case. Let's see. It helps, first of all, that we have two different parameters here. Sometimes the default is to just use t, and if they were both t, then it would be helpful to change one of them to make them different, because the point of intersection might happen, will likely happen, if at all, at different values of the parameters. And it might also be helpful to write, this is the vector form. It might be helpful to write in the parametric form. So the first line, L1, x is equal to negative 2 plus 3t, y is equal to 1 plus t, and z is equal to 5 minus 2t. Z is equal to 5 minus 2t. And for line 2, x is equal to 3 plus s, y is equal to negative 6 minus 4s, and z is equal to negative 3 minus 3s. Okay, so at the point of intersection, xyz will equal xyz. So we will solve the system of equations. Negative 2 plus 3t equals 3 plus s. 1 plus t equals negative 6 minus 4s. And 5 minus 2t equals negative 3 minus 3s. So the 2 by 2 system that we see here will likely have a unique solution, because this represents the intersection of 2 points in the xy plane. And then when we find that point of intersection, it may or may not solve this third equation. So first we'll solve the first 2 equations simultaneously for s and t, and then we'll check that the third one is solved. And if it is solved, then we have a point of intersection. So I think the easiest way to solve this is, and let's get rid of s because it can look like a 5, solve the first equation for s. So the first equation says s equals 3t minus 5. And now let's plug that in to the second equation. So 1 plus t is equal to negative 6 minus 4 times s, which is 3t minus 5. So 1 plus t is negative 6 minus 12t plus 20. And so 13t is equal to negative 6 plus 20 is 14 minus 1 is 13. So t is 1. And then coming back up here, s is equal to, if I put t equal to 1, 3 minus 5 is negative 2. So s is negative 2. If we put t equal 1 and s equal negative 2, then the first 2 equations will be solved. They'll hold. It'll be true. Let's check the third one. If t is 1, then this is a 3. And if if s is negative 2, then this is negative 3 plus 6, which is 3. And this equation was with the x coordinates, y coordinates, the z coordinates. So the point of intersection, if we plug in t equals 1, then we'll get the point of intersection. Or we could plug in s equals -2. We know the first two equations will hold, and now we just saw that the third equation hold, and moreover, the z coordinate is 3. The x coordinate is 1. Again, plugging in t equals 1, or s equals -2, give x equals 1. And plugging in t equals 1 gives y equals 2, and double check it again. If we plug -2 in here, -6 plus 8 is 2. So this is our point of intersection. The two lines in space did in fact intersect.